If your swimmers aren't getting the job done underwater, it becomes more and more difficult for them to win races and for them to go fast. And while most people will focus on how much propulsion is being created during underwater kicking, in many cases, the key to fast underwater kicking is optimizing alignment to minimize resistance. It's more about taking away the brakes as opposed to adding more gas. Hi everyone, Andrew here, helping you help your swimmers get faster. And in this video, we're talking about how to improve underwater kicking. And in particular, we're talking about how to minimize resistance. So we're going to cover why minimizing resistance is so important. We're going to cover the key skills that swimmers need to be able to achieve and execute in order to minimize resistance. We're going to talk about the challenges of helping swimmers learn this important skill, and we'll go through solutions that you can use to help swimmers develop this key skill so that they can go faster underwater. Finally, I'll show you a couple sets that you can use as starting points to implement some of these ideas. Let's check it out. So why does minimizing resistance matter? Well, speed in all the strokes, and certainly with underwater kicking, comes down to propulsion and resistance. When propulsion is a lot more than resistance, you get speed. And so if swimmers are creating a ton of resistance and very little propulsion, they're not going to go anywhere. But if they're creating a lot of propulsion and they're creating not very much resistance, they're going to go fast. And so if you want to help swimmers go fast, you have two options. You can help them learn to create more propulsion, or you can help them learn to create less resistance. So resistance is half the equation when it comes to speed. Unfortunately, most of the focus is on learning how to get more propulsion from the kick, focusing on the kick itself, rather than the body shape, the body vessel that's traveling through the water. And the reality is swimmers can't go fast when the brakes are on. And so if they're creating a ton of resistance, it doesn't matter how much propulsion they create, they're not going to go fast. The other aspect, and the much less appreciated aspect of minimizing resistance, is that to create more and more propulsion, it requires more and more energy. So swimmers have to be fitter and fitter and fitter in order to execute more and more propulsive kicks and sustain those kicks over the course of a race. In contrast, eliminating resistance will increase their speed, but not only does it not cost more energy in order to execute these skills, it actually costs less. So underwater kicking speed that's a result of minimizing resistance actually improves endurance because it's simply easier to execute those skills for longer periods of time. And as I'm sure you've seen in races, it's not just what happens on the first wall, it's what happens on the last wall that's really matters. And some of that is fitness, but if you can just have swimmers use less energy to create speed, their fitness is necessarily going to improve even if their metabolic fitness hasn't got better. Their ability to execute skills for longer periods of time will improve, and that's another really important aspect of why minimizing resistance during underwater kicking is so important. So what is it? Well, it's all about optimizing amplitude. So when swimmers have a bigger and bigger kick, a bigger and bigger range of motion of the body, they're going to create more propulsion and they're going to create more resistance. In the opposite respect, the less amplitude they create, the less resistance they'll create and the less propulsion they'll create. So swimmers have to find the sweet spot, which maximizes the amount of propulsion they create and minimizes the amount of resistance they create. And that's going to be a little bit different for each swimmer. At lower amplitude levels, when the swimmer expands the amplitude a little bit, they tend to create more propulsion than they do resistance. However, at a certain point, they start getting less and less propulsion and more resistance. So there again is going to be that sweet spot where they create as much propulsion as possible and as little resistance as possible. And that's what they need to use in order to create as much speed as possible. So minimizing resistance is ultimately about having an optimized amplitude. The second key skill is keeping the spine straight. And so the shape of the vessel, which is really dictated by the spine, is going to determine the speed of the vessel. If the spine is kind of rounded or it's really arched, it's like putting on the brakes. You want swimmers to be going through the water as straight as possible, and the straighter they can stay, the straighter they can swim, the less resistance they're going to create. And obviously they're going to be undulating around that straightness, but if they're trying to undulate around a position like this or a position like that, it's going to create a lot more resistance. So the straighter they can be, the straighter the baseline they can be, the less resistance they create, the more speed they create. Another key aspect is that we want the range of motion through the torso to be relatively controlled because that's going to minimize the amount of resistance they have. But if swimmers can still use a relatively large amplitude through their kick, that means they can create a lot of propulsion without creating a ton of drag, a ton of resistance. So if swimmers can learn to move the legs through a proportionally larger range of motion than they do the spine, they're going to optimize the amount of propulsion they create and minimize the amount of resistance they create. Again, the optimized amplitude is going to be a little bit different for each swimmer, but in both cases, we want a bigger amplitude with the legs than there is with the body, and that's going to create more propulsion with less resistance. So if we watch this swimmer here, the first thing to notice is look how relatively straight his spine is. There's not a big curve in either direction. He's pretty much straight from hands to hips, and you can see that's a really straight line, which is going to create a lot less resistance. The other aspect of it too is there's not a whole lot of range of motion through the torso and the spine, but look how much range of motion he's getting through the legs. He's kicking way in front of the body, and that's going to allow him to create more propulsion with less resistance. So this swimmer in particular has a relatively tight amplitude, especially with the upper body, and he's got a pretty big amplitude with the lower body, and that's what we're looking for. And he's keeping the spine really straight, which is also really important. So this swimmer here has a little bit more range of motion. There's a little bit more amplitude to the kick. However, if we watch the spinal action, the spinal movement, you can see his spine's still pretty straight. He doesn't have a huge arch. He doesn't have a huge curve. He's keeping things pretty straight, even though the upper body is moving more. And the same thing too with the legs. You can see that they're moving through a really big range of motion relative to the upper body. So again, even though this swimmer is using more amplitude, more range of motion, he's still keeping the spine straight, and the legs are moving more than the upper body. So he's going to get more out of the kick while still minimizing the resistance that he creates with the upper body. So with those two swimmers, you see the same principles demonstrated, even though they do so in a slightly different way, with one swimmer keeping a tighter amplitude, another swimmer having a more open amplitude, but in both cases, relatively straight spine, and the legs are moving through a much larger range of motion than the upper body does. So why doesn't every swimmer have unbelievable underwaters? Why is it difficult to help swimmers learn this key skill? Well, the first challenge is what's optimal. As we just saw, two really good underwater kickers have different amplitudes, have different ranges of motion, and so how do we know which one's going to be better? Swimmers have different structures, they have different joint ranges of motion, and that's going to really dictate how much amplitude they should use in order to have the most speed, in order to minimize resistance and maximize propulsion. So optimal is going to vary pretty widely across individuals, and again, how do you know what's going to be best for each one person? Second, underwater kicking happens fast. The cycle rate is a lot faster than all the other strokes, and so the movements are happening really fast, and so it's really difficult for swimmers to think their way through things. They have to be able to just kind of do it. And so if swimmers can't figure it out, they can't feel it, it's going to be really tough for them to think their way through it, because as soon as they start to think about whatever they're trying to execute, it's already too late. What needs to happen has already happened, and they're not going to be able to make the adjustment that they want. And so because of the fast speeds, it becomes more and more difficult to execute these skills. Lastly, it's a very subtle skill. Minimizing resistance is all about slight changes in posture and slight changes in amplitude, and it's very difficult to see, and it can be difficult for the swimmers to feel, and even small changes can lead to really big differences in terms of what happens. So if swimmers can't see it, you can't feel it, and it's hard to explain, we're going to have a challenge in terms of helping swimmers develop these skills. And so what it really comes down to is swimmers have to be able to feel the skills, they have to be aware of the skills, and as coaches, we have to provide them with the opportunities to actually develop the ability to feel what they're doing and then start to make those changes. So we talked about why minimizing resistance underwater is so important. We've talked about what it looks like. We've talked about the skills that swimmers have to execute. We've seen what it looks like, and we've talked about why it's difficult to help swimmers develop this skill. So now let's talk solutions. We're going to go over 2 drills that you can use to help swimmers become more aware of the resistance that they're creating. And then we're going to go over 2 training strategies that can further help swimmers learn how to feel, what to feel, and become more aware of what they're doing and whether they're executing those skills in ways that create speed. So let's check it out. The first strategy is amplitude manipulations. So what you're going to do is have swimmers explore lots of different ranges of motion with their kick. The more they explore, the more likely it is they're going to figure out what works for them. Again, because of the individual differences, it's really difficult to know exactly what a swimmer should do, exactly how much amplitude they should use, so we have to give them the opportunity to figure it out for themselves. If we use really big kicks, we use really small kicks, we transition from high amplitude to low amplitude, from low amplitude to high amplitude within the same repetition. We let them explore it in lots of different ways. They're going to start to pick up on what creates speed, what creates a lot of resistance, what creates a lot of propulsion, and what works. Again, if we can't know what the best solution is, we have to provide them with the opportunity to figure it out for themselves. And you can use tons of different variations. You can use different training aids like fins, like drag socks. You can have them do it at different speeds, at different kick rates. You can have them explore different amplitudes with any type of underwater kicking drill, whether that's a kick on the wall, whether that's vertical kicking, where it's just straight up underwater kicking. You can also have them play with different positions, whether kicking on their side, on their front, or on their back. They're all really great ways to help swimmers explore. The more they can explore, the more they can figure out what consistently leads to faster and easier swimming, the more likely it is they're going to figure out what to do and how to make that happen. So here are a couple examples. This swimmer's starting off with a really big kick, and he's going to gradually try to keep things tighter and really make things smaller. And so this is an example where you can help swimmers feel what happens when they move from a big kick to a small kick. How does that change how much resistance they can create? How does that change how much propulsion they can create? And what's the balance between the two that ultimately leads to speed? And then the flip side here is they're starting really big, and then they're getting bigger and bigger and bigger. And again, it's the same idea, it's just a different context. And so what's really important is that you can do it in lots of different variations. This swimmer's on the side. He's using fins. He's got his arms in streamline. You can have him do it lots of different ways. You can use fins. You can not use fins on the stomach, on the back. You can go from low to high, from high to low. You can go all low and then alternate with all high. There's tons of different options. It's the principle that's really important is you're helping them feel big kicks, small kicks, and then what creates the most speed for the least amount of effort. The next option is to alter the streamline. So if we can create more resistance, we can help swimmers better feel the resistance. And so they're going to have that contrast between having a streamline and not having a streamline. They're going to feel all that resistance flowing over their body. And so you can have swimmers go with their arms across the chest. You can have the swimmers go with their hands behind the head. And in both cases, they're going to feel a ton of resistance across their head, across their shoulders, over their stomach, over their back. And that's going to help them become more aware of how they're sliding through the water, particularly when they alternate between using an altered streamline and a regular streamline. Another benefit is that the streamline itself tends to dampen the amplitude. It tends to help swimmers control the amplitude, and it's going to be a lot more difficult to control that amplitude without the arms in streamline, but that means they have more control over what they do when they add it back in. And again, that contrast is really valuable for helping swimmers feel and figure out how to manipulate their undulation, how to manipulate the amplitude of the undulation, and how to control that with their upper body. And that's really what tends to dictate how much amplitude they use. So if they can better control that, they can better feel that, they're going to be more equipped to find an optimal amount of undulation, an optimal amount of amplitude that allows them to minimize the resistance they create while still creating a ton of propulsion. So here we have a swimmer, arms crossed behind the head, and he's going to have to control the amplitude. He's also going to create a ton of resistance. You can just see how much resistance is going to be smacking into his forearms, smacking into his head. And then when he goes back to regular underwater kicking, he's going to have more control over the amplitude. He'll have the ability to make it bigger or smaller depending on what he's feeling. And he's going to be much more aware of the resistance that he's creating, because now he's going to feel like he's just slipping through, and that's going to feel a lot different. Whereas if he hadn't done the extra resistance before, it would just feel normal to him. Same here with the arms across the chest. He's going to have even less control over the amplitude that he has. He's going to feel even more resistance, and so it's an even better strategy when you're looking for really great contrast to create a ton of resistance and really help them learn how to control their amplitude, the range of motion that they create in order to create speed. So as we talked about before, a huge part of helping swimmers learn to minimize resistance is helping them feel the amount of resistance that they're creating as they move through the water. And unfortunately, regular underwater kicking isn't particularly effective at that. One, because swimmers have done it so many times, but two, there's just not a whole lot of resistance. And so for swimmers to become more aware, using training aids is a really powerful tool. And we've got three options here. One, we can go over speed, which is usually fins, but can also be done with a cord. We've got clothing, which can be t-shirts or shorts, whatever else you can think of having swimmers wear. And then lastly is a weight belt. And so with overspeed, the extra speed means that there's going to be more drag, which means swimmers are going to be better able to feel the resistance that they're creating. And for instance, if we use that with the exercises that we just talked about, having the arms across the chest or behind the head, then they're going to feel even more resistance because they're going so much faster and they're using the fins. Clothing can also be really useful because swimmers are going to be much more aware of the drag that's being created as they move through the water when they're wearing a t-shirt, for instance, and they can feel that resistance and they can feel the impact of their amplitude. But then when they take it off, now all of a sudden all that water is going to be flowing over their body, which wasn't previously. It's going to be flowing over their skin specifically, and they're going to be a lot more aware of what's actually happening. And if they're more aware, they can start to make some subtle adjustments. They can start to manipulate their amplitude, control their spine, to minimize the amount of resistance that they're creating. And so if the resistance they feel is at a level 9, if they can get it down to a level 8, that's going to be a pretty big improvement. And so it's just about being aware and feeling these skills, and then they can start to change them. Lastly, a weight belt, having all the resistance on the hips, is going to help swimmers better feel how the hips are moving through the water, the resistance that they're creating, and it's going to help them learn to control the movement of the torso which again, as we talked about earlier, having that relatively controlled torso is important to minimizing resistance and still allowing for a lot of propulsion with that bigger leg kick. Finally, performance is a great way to help facilitate change. So by using different kick rates and using different speeds, we can challenge swimmers to perform using any of the previous strategies. So the drills themselves, the training aids, and combining them in different ways, and then asking for performance is going to help them learn and force them to search for better solutions. They have to find speed, but they have to do so in the context of those different activities. You can then increase the challenge by asking for them to create speed at different kick rates. It's going to be harder to create speed at low rates, and some swimmers, it's going to be hard for them to execute great skills at fast rates. And so challenge them at both ends of the spectrum is really great and really effective for helping them learn these skills. You can also have them try to go as far as possible for, say, 10 kicks at a given rate, and so they can't slow the kick down to get more distance. They have to kick better at the same rate to get further with those, for instance, 10 kicks. Again, a really great performance challenge that when performed with those other activities is really going to force them and encourage them to search for new solutions. What's great about performance is that it gives swimmers something to calibrate with. It gives them a concrete goal to try to achieve, and it lets them know what works and what doesn't. If they use one strategy and they go 12 seconds for a 25, and they use another strategy and they go 11 seconds, and that happens over and over and over again, that provides them with some pretty good clues as to what works and what they should do if they want to kick fast underwater. And because they're using activities that necessarily stress the amount of resistance that they create, they're going to start to figure out solutions that require less resistance and allow them to go faster underwater. So here's a skill-based set to help swimmers improve their underwater kicking. They're going to go 4 rounds through. They're going to go 425s underwater kick with fins. They're going to go odds, low to high amplitude, evens, high to low amplitudes. They're going to explore really big ranges of motion, and they want to try to get as big as they can on the high and as tight as they can on the low. Then they're going to go 412.5s underwater kick, build a strong, the odds, arms across the chest, evens across behind the head, and that's going to challenge them to create stability, to minimize resistance as they go, and they're adding speed to that as well. 50 swim choice, 12.5 strong underwater each wall. They're going to descend 1 to 4 in the swim. The underwater stays strong throughout. It gives them a chance to put it together, see if they can make it happen when they swim. For round 1, they're going to wear a t-shirt on the 25s and the 12.5s, and that's going to create more resistance, help them really feel what they're doing. Same thing with shorts on round 2 and weight belt on round 3, and then they're just going to try to put it all together on round 4. So they're exploring different ranges of motion. They're using different streamline positions to help them learn to control the range of motion and feel the resistance, and we're using the different types of training aids to help them become more aware of the resistance as well. So really challenging them in a lot of different ways to help them feel how much resistance they're creating and ultimately try to change that. Next set, a little bit more of an endurance feel. So they're going to set up each round with 425s underwater kick with fins and a t-shirt. They're going to descend 1 to 4 to fast at the same kick rate. So we'll start off at 0.75 seconds per cycle, drop it down to 6.5, 5.5, 4.5. 7.5 is not particularly fast, 4.5 is pretty fast. So what they have to do is they have to find a way to create speed without picking up the rate. And that's the real challenge, and it becomes more difficult to do that when the rate is already really fast. Then they're going to go into some longer swimming where they try to execute really great kicks, have really great alignment, and by using the fins and the t-shirt, they're going to be going really fast because of the fins, and they're going to get all that sensation, all that awareness of the resistance because of the t-shirt. And then when they take those off, they should feel like they're just sliding through the water when they do the next piece. And so the next piece, they're going to go 300, 2 150s, 3 100s, 650s. They're going to go 4 strong kicks each wall, and then 5, 6, 7 as they drop the distances down, and the overall time needs to get faster as they go. So there's more and more emphasis on the kick, and they're trying to be better and better on those 25s and then carry those skills, whatever they learn, whatever they figure out, into the longer swimming and apply those great kicks while they're actually swimming. This last set is geared more towards creating speed underwater. They're going to go 6 rounds through. They're going to go 12 underwater kicks with the arms crossed behind the head. They're trying to get as far as possible at 6.0 seconds per cycle. So they can't move the feet slower to create more distance, so they got to create as much distance as they can at the same kick rate. The challenge with that is they got to get more out of each kick, and they got to do so with the arms crossed behind the head. Then we're going to do the same thing with the arms across the chest. Then they're going to do the same thing with regular dolphin kicking, and then they're going to go 25 fast with 15 meters underwater off each wall. So the first round, they're wearing either t-shirt and shorts, so they're going to get extra resistance on the body, no equipment on round 2, and that's going to continue that pattern. So the odd rounds are with extra resistance on the body, and then the even rounds are without equipment. And then the kick rate's going to drop from 6.0 to 5.0 to 4.0. That's going to make it a lot more difficult to get kick length However, swimmers are going to have to execute those skills at really high rates if they want to go fast underwater. So they got to figure out how to minimize resistance, create as much length as possible, even at really high kick rates. If they can do that, they're going to swim fast underwater. So we're challenging the skills with performance, we're challenging the skills with resistance, and we're challenging the skills with different drills that require them to be really good with controlling their amplitude and minimizing the resistance they create as they move through the water. And each round we give them a chance to put it all together with some fast underwater kicking, both on its own and transitioning to really fast swimming. If you want to learn more about the other half of the underwater kicking speed equation, check out the video below to learn how to help swimmers create a lot of propulsion underwater.